Let us look at another example. So this is the example wherein the mirror is kept horizontally as shown. Now let us say the observer is located over here. I represent the observer with this point. Then the field of view of this observer in this mirror as shown is going to be obtained by drawing a ray diagram from edge point to edge point. Alright, so the field of view is nothing but this region right over here. Any objects located within this region will be such that their image will be seen by the observer located at O. Any objects that are not within this region will be such that their image will not be seen in this particular mirror by the observer located at O. Let us take a typical example of a boy who is looking at his own image in the mirror. Alright, so we are to find out what is the minimum height of the mirror required such that the boy will be able to check out or look at his particular image. So here in this particular problem statement, the mirror is movable. So we can move around the mirror. They have not specified, or it is not specified whether the mirror is fixed or movable. In such a case, we can assume the mirror to be movable. Alright. Now let us say we adjust the mirror in such a manner that he is able to see his own complete image. Alright. In that particular case, the observer will be able to see his feet, as well as the observer will be able to see his eyes. That means in the process of, or rather not his eyes, the top of his head. So this is the ray diagram that I am looking for. So the ray that is coming from the top of his head will get reflected in the mirror and enter his eyes, and the ray that is coming from his feet also will get reflected and enter his eyes. And we need to adjust the mirror such that this scenario is possible. That means here I need to increase the length of the mirror by some amount. So I have now increased the length of the mirror to accommodate our ray diagram. Alright, now given the fact that this is the minimum length of the mirror required so that this observer can observe his entire self, let us try to find out what is the length of the mirror with respect to his height. Alright, for this we construct the normals at the two points of reflection. This is one normal, this is another normal, let us say. Alright, now we know that the angle of incidence is equal to the angle of reflection. So I1 is going to be equal to R1. Similarly, I2 over here is going to be equal to R2. That means that, let us say if this side is X, then this also has to be X, because in this diagram these two triangles are congruent. So what I am saying is, if this is X, this also has to be X, because this is I2 and this is R2, and I2 happens to be equal to R2. So by ASA test, because this angle is 90 degree, by ASA test these two triangles are congruent, and therefore the two base sides are X. Similarly, this particular length is, if it is Y, then this particular length also has to be Y. Now let us check out the mirror. The length of the mirror is nothing but x plus y. We can understand this, that this is x and this is y. So the length of the mirror is nothing but x plus y. So we don't really bother about what x is and what y is. All that we need to understand is that height of the observer happens to be 2x plus 2y as seen in the diagram, and the length of the mirror L, length of the mirror, happens to be x plus y. So from these two equations, it is obvious that the length of the mirror has to be height divided by 2. And since we are utilizing the entire mirror for this purpose, meaning the rays have reflected from the edge points of the mirror, that means that this is the minimum length of the mirror required. So the minimum length of the mirror required is h by 2. Also, let us note another interesting fact. Let us say what will happen if we try to bring this mirror closer to the observer. Let's try to understand what happens. Let's say if I bring the mirror closer to the observer. So what essentially happens is that in the ray diagram, we'll have to draw a ray that goes from the eyes of the observer and gets reflected. Okay, so that ray may not reach the top of his head. Similarly, the ray that goes from his eye and gets reflected from the other point may reach beyond his legs. If the mirror is even closer, let's say the mirror is over here, then in that case the ray that starts from the eye of the observer may go something like this, and the ray may go something like this. Alright, so we can actually see that as long as the mirror is located in this particular region, the observer is always able to see himself as long as the mirror is located over here. And as soon as the mirror is located like off this particular region, let us say if the mirror is over here, also the ray diagram is such that the observer can see himself. So anywhere, if the mirror is shifted parallelly anywhere vis-a-vis this particular region, then in that case the observer is able to see himself. And if the mirror is shifted like this, then in that case the ray diagram will change in such a manner that the observer will not be able to see himself. So let's understand that. So this is the midpoint of the line segment that goes from the eyes of the observer to the top of his head, and this is the midpoint of the line segment that goes from the eyes to the bottom of the observer. So let me draw a horizontal line from these two midpoints. So what we mean to say is, if this particular mirror is within these two line segments, then in that case, no matter where the mirror is located, no matter where it is located, if it is ahead or if it is behind, or like if it is close to the observer or if it is further away from the observer, that does not really matter. as long as it is located within these two line segments, you will always get a ray diagram that looks like this, wherein these two triangles are going to be congruent and these two triangles are going to be congruent, no matter where the mirror is located. That's why you will always be able to see, or the observer will always be able to see his complete self. But as soon as we move the mirror somewhere away from these two line segments, now let us see what happens. Now the observer simply is not able to see himself completely because the field of view changes. Now the observer, his complete body, even though the length of the mirror is h by 2, it, it, it is able to, the mirror has sufficient length to be able to encompass the entire observer in its field of view. However, the observer will still not be able to see himself because the mirror is not located in between these two parallel red lines shown over here. These two red lines, let me remind you, are drawn from the midpoint of the line joining the eye to the topmost point and the midpoint of the line joining the eye to the bottommost point. So these 2 points are essentially the middle points. Let us say this point is M1 and this point is M2. So if the mirror is located between these two red line segments only, the observer will be able to see himself completely, no matter how close or far away the mirror is with respect to the observer. Else the observer will not be able to see himself if the mirror is located away from these two red line segments. Now this also makes us understand another interesting fact. Let us say these two red line segments, let me redraw them. Are as shown. Alright. Now let us say a mirror is greater than h by 2 in length. So let us say this particular mirror is greater than h by 2 in length. Alright. Then the observer will be able to see himself or herself in the mirror provided this mirror encompasses this particular region that lies between these two red lines. So if the mirror is like this, still the observer will not be able to see their complete self. If the mirror is like this, still no. Now if the mirror encompasses the region that is required for the observer to see themselves completely, that means the mirror is reflecting in this particular region that lies between these two red lines, then the observer will be able to see themselves completely again. So right now, even though the mirror is more in length than what is required, still the observer will not be able to see themselves. Only if the mirror encompasses this particular region, then the observer will be able to see themselves. Quite interesting.